Hello all, this is a Python GUI tKindle application featuring machine learning libraries. This application right now has two widgets, expected ROP and predicted ROP. Expected ROP is an ROP calculated based on the assumption that the ROP is going to behave in a linear fashion, and therefore it will plot its ROP based on that linear straight line, and hence the ROP will be less comparable with the actual data output. The predicted ROP is based on the assumption that ROP is going to fluctuate as it progresses, and hence the ROP calculated will be highly efficient and highly comparable with the actual observed data point in the database. Now I'm going to select the file that I want to use for calculating the ROPs. Okay, this is an Excel data sheet. Okay, here we have data in columns and rows. We have depth, ROP, weight on bit, RPM, torque, flow, SPP, mid-weighting, and D-exponent. I have used D-exponent for better correlation of the data. It also increases the efficiency of the model. Here you can see when the drilling was stopped, the ROP was 47.6, 13.5, 129, 1380 torque, RPM of 129, flow of 665, mud weight of 9, the exponent of 0.89. Okay, now the estimate ROPs tab will be clicked in order to calculate these two ROPs. Now you can see a plot of ROP trend plotted against ROP. The blue linear straight line is the trend line followed by expected ROP, which is following the linear model, whereas predicted ROP is following a curvilinear model, and the trend line, as you can see, is a curvilinear trend line. Now, a data input section and output section widgets are displayed here. This section helps optimize the output parameters like ROP, weight on bit, RPM, torque, and flow. These input parameters can be used to optimize the output. For example, we have seen that in the Excel data sheet, the last row was having 13.8 as the weight on bit, and RPM was 129. 129. This was 13.5. Okay. Torque is 1380 and flow of 667. 1380, 667, and the exponent of 0.89. So now when I click, I get a 51 meter per hour ROP, which is highly comparable with the predicted ROP displayed here and comparable with the ROP in the last row. Okay, now if we want to increase the weight on bit, say 25 kilopounds, and we want to drop the RPM, and we also want to drop the flow, so we are going to get an increase in the ROP because we have increased the weight on bit. Say if we increase the flow here to 650, which was earlier the case, the ROP increase, if you increase the flow, is not significant. But if you increase the RPM, it can be significant. But if you increase the weight on bit, it can be very high because weight on bit is the main factor here in this model for change in ROP. Okay, I will revert it back to the original one, 13.87, 139, 129, 129, 1380, 667, and it's 51. So now let me fill this empty input ROP column with the output ROP which I obtained here. Rest of the parameters are filled up. Okay, we got a weight on bit of 13. Okay, and here you have ROP filled up, weight on bit filled up, torque filled up, flow filled up, the exponent filled up. What is not filled up is the output. Unless and until we click the apply button or the parameters are applied, the RPM won't be calculated. So I clicked apply and RPM is calculated. Similarly, I can calculate the torque, which is close enough. I can also calculate flow, which is slightly higher as compared to the rest of the parameters. Still, it is within the range. The model has higher efficiency for ROP, weight on bit, RPM, and torque, and lesser efficiency for flow. This model can be further refined by adding lithology and the hardness of the lithology. Also, gamma ray can be a major factor for strengthening the model. This application helps decision making faster as when a difficulty situation as far as drilling progress is concerned arise, this application can help calculate or forecast the ROPs with the required inputs. Cross-checking the parameters will be helpful for the decision makers. Thank you for watching.